You know, there's this incredible secret hiding in plain sight, inside every flat shape you can possibly draw. I'm talking everything from a basic triangle to a huge sprawling octagon. It's a magic number that is always, and I mean always, the same. Today, we're going to uncover that secret, but we're not going to look inside the shape, we're going to look outside.
So first off, what are we even looking at here? These are called exterior angles, and you find them in a really simple way. You just take one side of a polygon and keep drawing it, extending it straight out. Then you do the same for the next side, and the next, always going in the same direction, kind of like you're spiraling out. And the coolest part? It doesn't matter if you go counterclockwise, like we are here, or if you go clockwise. Each one of those angles on the outside is an exterior angle.
Okay, so here's the big mystery. If you were to add up the degrees of every single one of those outside angles on any closed shape, what number would you end up with? For a triangle? A square? What about this octagon? Or a shape with 100 sides? You'd think the answer would change, right? Well, let's find out. We're going to crack this code in 3 totally different ways. The first method is what I like to call the inside job. This is kind of the classic logical way to do it, where we use what we already know about the inside of a shape to figure out what's happening on the outside. Now, what's so wild is that any polygon, doesn't matter how complex it looks, can be chopped up into a bunch of simple triangles. And we all know triangles are special, right? Their inside angles always add up to 180 degrees. So that lets us figure out the sum of all the interior angles. But how does knowing the inside help us with the outside? Well, here's the bridge. At every single corner or vertex, the inside angle and its buddy, the outside angle, are sitting right next to each other on a perfectly straight line. And a straight line is always 180 degrees. This is our connection. If we know the sum of all the angles inside, and we know the sum of all these straight lines, we can totally solve this puzzle.
And when you run the numbers, when you take the total of all those straight lines and you subtract the total of all the angles on the inside, you are always, without fail, left with this exact number, 360 degrees. It doesn't matter how many sides the polygon has. It always works out to 360.
Okay, I know that was a little bit of math, but what if there was a more intuitive way to see this? A way you could actually feel it? For our second proof, let's just take a little walk. All right, meet our little traveler. He's going to help us picture this by literally walking around the edge of our octagon. I want you to pay really close attention to how he turns at the corners.
So, our little guy walks along one edge. When he gets to a corner, he has to turn to line himself up with the next edge. And that turn, the angle he has to pivot, it is exactly the same as the exterior angle at that very corner. So he walks, he turns. He walks, he turns again. Every single turn he makes is one of our exterior angles.
Okay, so after walking along every side and making every single turn, our traveler is right back where he started, facing the exact same direction he was at the beginning. Just think about that for a second. What do you call it when you turn and turn and turn until you're facing where you started? Well, you've just made one complete rotation.
And how many degrees are in one full complete rotation? You know this one. It's 360. The sum of all his little turns, which were the sum of all the exterior angles, had to, by definition, add up to one full circle. I've absolutely saved my favorite proof for last. This one needs no numbers, no walking, just a simple change in how you look at it. I call it the cosmic zoom, and it's just a pure, powerful visual aha moment.
We're going to start with our old friend, the octagon. We see the sides, the corners, and those exterior angle lines shooting out into space. Now just imagine we're looking through a camera, and we're about to start pulling back, way back.
As we zoom out, the octagon itself just starts to get smaller and smaller. The path our little traveler walked is becoming less and less important. But look, notice what's happening with those angle lines. They're all starting to look like they're coming from the exact same place.
And now, we zoom out so far that the octagon itself is just an insignificant little dot in the middle. The journey around it doesn't even matter anymore. All that's left are the turns, and they come together to create this absolutely brilliant picture of the entire concept.
I mean, just look at that. The lines that represent each and every one of those exterior angles have all come together at a single point, and together, they perfectly form a complete circle of rays. It's just a stunningly simple and elegant way to prove it.
And what do we see yet again? A circle, 360 degrees. 3 completely different proofs, and every single one of them lands on the same unshakable answer.
So, the big takeaway here is that this isn't just some neat trick about octagons. This is true for any simple, closed polygon you can possibly think of. A triangle, a pentagon, a dodecagon, some crazy shape with 1,000 sides. If you walk its perimeter, the total amount you turn is always 360 degrees.
And that just leaves us with this final, really fascinating thought. It's a fundamental rule of our world. No matter how many stops you make, no matter how jagged or complex the path is, the total spin required to complete any closed trip and end up facing home is always one perfect circle.